Today we're going to talk about complex numbers. Within complex numbers are imaginary numbers. Imaginary numbers are just numbers that have negatives inside square roots. For example, the square root of -1 here. The square root of -1 is an imaginary number we call I. So if we square I, we would actually get -1. And if we square -I, we would get +1. So anytime we have a square root of a negative, we just put an I out there, and that's the square root of -1. So a complex number written in standard form is of the form a plus bi, where a and b are real numbers, I is an imaginary number, and then of course the a is the real part, and the bi is the imaginary part. So what are real numbers? Well, real numbers have 0 as the imaginary part. Therefore, there is no imaginary part to it. It's just a real number. Pure imaginary numbers have no real part, which 0 is the real part. Therefore, it's only the imaginary number. Imaginaries, or complex numbers, have a real part and an imaginary part, where the imaginary part must exist, so b cannot be 0. So those are your imaginary numbers. All together, these are the complex numbers number system. So let's solve some equations that may have some imaginary answers. First one, letter A, we have x squared equals -9. So we would solve this by taking the square roots of x squared, and a square and a square root will cancel out. So we'll get x by itself. And if you remember from yesterday, anytime we take the square root, we always get a plus or minus. And the square root of 9 is 3. And the square root of negative, or a -1, is I. So the square root of -9 is positive or negative 3i. We look at letter B. We must first subtract 12 to both sides, and we would get 2x squared equals -8. Then we would divide by 2, and we would get x squared equals -4. And then we have the square root, get rid of the square. The square and the square root will cancel out, and we will get x equals plus or minus, because we took the square root. Square root of 4 is 2. Square root of a negative is I. So x equals plus or minus 2i. Let's try letter C. The first thing we want to do is add 4 to both sides. So the positive 4 and a -4 will cancel out, and we get -y squared equals 28. Now we have to get rid of the -1 that's in front of the y. So we divide by -1, and we get y squared equals -28. And the last step would be to square root to get rid of the square. Square and the square root cancel out. We get y by itself equals plus or minus, and now we have to do the factor tree. Because 28 is not a perfect square, we got to find perfect square factors. So factors of 28 are 4 and 7. Factors of 4 are 2 and 2. So we got a pair of 2's. Left over 7. Don't use the 4 anymore because it factored into the 2 2's. So our answer is going to be plus or minus 2. Because we had a pair of 2's, we pull our pairs out. Because we had a negative, we have to put an I on the outside. And then what's left over goes back in the fridge, which is a 7. So we get plus or minus 2i radical 7. And that's our answer. Let's try the next one with parentheses. So the first thing we have to do here is isolate the parentheses. To do that, we would subtract 4 to both sides to cancel the 4 out. We would get 1/4 times the quantity of a minus 5 squared equals -10. And now we have to get rid of that 1/4. So we would multiply by 4 on both sides. When we multiply by 4, the 4's cancel out. You'd be left with a 1, but you don't need to write the 1. So the quantity of a minus 5 squared equals -40. And the last step would be to get rid of the squared, which is 2 square root. The square and the square root would cancel out. We would get a minus 5 equals the square root of 40. Well, once again, we have to do the factor tree. So that's 4 and 10. 10 factors to 5 and 2. 4 factors to 2 and 2. We have a pair of 2's, left over 2, left over 5. The 4 and the 10 factored further, so I just cancel those out. So I have a pair of 2's, therefore I write a 2 down. There's a negative sign there, so I have to put the I on the outside of the radical. And inside the radical, I'm going to put 5 times 2, which is 10. And don't forget, because we took a square root, we got to put a plus or minus here. And to get the a totally by itself, we have to add 5. 5's cancel out. We get a equals 5 plus or minus 2i radical 10. And that would be our answer. Now, if we were going to graph these complex numbers, we're going to have a real axis, which is this red horizontal axis, and we're going to have an imaginary axis, which is this blue vertical axis. So if we have the real part, we go right or left. If we have the imaginary part, we go up or down. So let's take a look at some examples that we can graph here. So we get 5 plus 4i. So 5 is a real part, so we would go right 5. 4i is the imaginary part, so we would go up 4. So right 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4. Put a dot, and that would be the point A. Let's try 7 minus 2i. Well, 7 is the real part, so that's the real part. 2i, or negative 2i, is the imaginary part. So we go right 7, 1, 2, 3, 4, 5, 6, 7, and down 2, 1, 2, and that would be the point B. Next one, we got negative 1 plus I. So negative 1 is the real part, so we would go left 1. I is the real part, or the imaginary part, so we would go up 1, put a dot, and that would be the point C. And the last one we want to plot is negative 7i. There is no real part, so we don't go left or right. We just go down 7 on the imaginary axis, so down 1, 2, 3, 4, 5, 6, 7, and put a dot, and that would be the point D, which would be on the imaginary axis. And that's how you graph real and imaginary numbers, or complex numbers. We can also add and subtract complex numbers. The way we add and subtract is just like when you're adding a variable or adding like terms. So if I see a subtraction sign in the front, I just assume there's a negative 1 here. I'm going to distribute the negative 1, so I get 5 plus 3i minus 4, and then a negative times a negative is a positive 2i. So now I just combine like terms. So I have a 5 and a negative 4. 5 minus 4 is 1. And I also have a positive 3i and a positive 2i, which would give me positive 5i. And that's what you get when you add those like terms. So the next one, we just have parentheses. There's nothing really to distribute because it's a positive, so it's negative 3 minus 5i plus 6 plus 5i. So at this point, I combine like terms. I have a negative 3. I have a positive 6. Negative 3 plus 6 is 3. And I have a negative 5 and a positive 5i. So a negative 5i and a positive 5i will cancel each other out. So the answer is just 3. There is no imaginary part to do that. And the last example here, example 3, we're going to subtract the negative 3 plus 9i, which basically means we distribute a negative 1 to the parentheses here. So we get 1 minus I plus 3 minus 9i, and then plus 5. And we're going to combine like terms. So 1 plus 3 plus 5 is 9. And negative I minus 9i is negative 10i. So 9 minus 10i would be our answer.